maybe tomorrow. Yeah, tomorrow you can ask a question related to this material in this course today. So this is aturan kuliah, the role of the course. So we are here. Yes. Any question? Okay. So you have to present at least 80%. Yeah? If this is less than 80%, then automatically you have failed. I mean, the mark is E in this case. So if you are not present because the sickness or something important, so you have to have a letter from the doctor or a letter from your parents or lembaga kemahasiswaan. Lembaga kemahasiswaan, what is in English ya? Student office maybe ya, ITB student office. So the letter of if you are sick, well, you don't have to go to doctor, so you have to sign this letter with your parents or your keeper, yeah, with the name and number, and the phone number. And the letter, the statement letter of your condition or your permission should give to LTPB, and it's copied to me as a lecturer in this class at least 1 week, yeah, after you are present in the course. And the mark, so this is statement. If you failed in experimental elementary physics, then you have mark E for this course, this elementary physics here, 2B. You get mark E. And the final mark is calculated based on first exam, second exam. This is AU2. AU1 is first exam, second exam is AU2. Or if you are sick or you have something important, you cannot you could not attend the exam. We will replace this either first exam or two exam with third exam. These experimental marks IP, this simple research exam also AR, and this is homework ya, AR. Angka lain AL means others mark, such as quiz, which is give by me as a lecturer, and also we have a common quiz, at least 2 in this semester, online, using MS Teams. So this is the normal marks if you attend first exam and the second exam. And then if one of you cannot attend either first exam or the first exam or second exam because sickness or your permission from parents, so we will replace this the third exam. We replace either first exam or second exam by the third exam, and you get the full remark. Okay. fully marked, I mean that you can get a perfect score like A, for example. And then the third case, if you fail, for example, you get D. Sorry. Oh yes, this is there is a statement here. If you cannot attend this first or second exams without the letter from the doctor or statement letter from your parents of your keeper or from student office ITB, so automatically you get 0 in this first or second exam. Okay, this is the normal indices. And if you get D in the final marks, well, the preliminary final marks, then you can have a third exam, but maximal mark, the maximal final marks should be C. Even you get 70, for example, in the final mark. So this case, this 1, 2, 3, 4, 5, yeah, 5. The first case, in this first case, it means that you have a normal condition. So you attend also the final exam. I'm sorry, you attend also the first exam and the second exam, but you still get D, and then you can also attend the third exam, and then you get maximal C. Or if you get the preliminary final marks, if you get E, you could also attend the third exam, which is the maximal marks is C. Yeah. Even you have 80 or 70 in your final marks after the third exam. Okay, any question with these points, with these 2 points? Presence and marks. Marking scheme, yeah, marking scheme. Any question?
No, sir.
Okay, okay, enough, okay. So this is the experimental. You have to, so the experiments, elementary physics experiments will be conducted as a schedule governed by this commonly with elementary chemistry experiments. And these elementary physics experiments consist of 4 modules, which will be executed online. I think online or offline. It depends on the situation. I don't know. Maybe in your case, if you live abroad, some of you it's maybe probably will be online, conducted online. The course will be online, and the class will be divided by groups, and the schedule of the experiments will be announced by the lecturer of the course of the class in the class or in the website in experimental physics laboratory at this website, https lfd.itb.ac.id. Okay. So the minimum for elementary physics experiments is 50. Yeah. So this is the point minimum you have to pass. Yeah, you have to pass. If you less than this is 50, you failed, and you have to remedial in the next semester. So just 1 second. Okay. So you have a question or something to ask or complain, you should ask the LFD, the chief of LFD, via email, this one, with subject and identity, student number, handphone number, which could be phoned by someone from LFD. Okay. Okay, so if you have a remedial for Fisika 1 or 2, I think it's not the case, I think, for us. So the experiment elementary physics 2 will begin on Monday, February 15. The detailed schedule and its explanation, you can see the LFD website here. So explanation about these experiments will begin on Monday until Friday, 15 to 19 February 2021. All practicant obligated to follow and to attend these experiments in this semester. So every ex-practicant is obligated to join the group line in each class. Yeah, using you can see also in LFD. You should watch and study the experimental video. Yeah, you could also see in YouTube LFD. The experimental module can be seen, can be viewed in the LFD website. So every practicant is obligated to know the group and each module which is accessed through the website LFD. I think you can read this. I will. You have already this one, yeah? this role of this course, especially for experiments. Any question, you should ask LFD at the website. And then miscellaneous. Okay, the examination will be conducted as schedule. You can see in this satuan acara perkuliahan, notice in English. Yeah. So the homework and others marking, yeah, are governed by each lecturer in the class. So also this research-based learning also will be coordinated by a lecturer in the class. So physics study program will give a sanction, academic sanction, for student which will do which is cheating, yeah, which are cheating, such that they are failed in this course. And also the student will have a sanction also from ITB. Any question you can ask this coordinator of elementary physics course, Dr. Nur Hassan, at this email. Okay, that is miscellaneous. Any questions?
No, sir.
Okay, good. I hope my voice is clear, yeah, in English. If you have any question or something you cannot clear about something, you can raise your hand. Okay. Or you can interrupt with voice also. Okay, let's okay. Okay, let's see. SAP aturan SAP. Okay, SAP. Oh yes, you know my name, yeah? Is anyone who doesn't know my name? Okay. Oh yeah, this is Bobby Gunara. Okay. I think it's already know my name. So this is the list of this course material in this course, this elementary physics course 2B. And this is code. So in the first week, we will discuss about force and electric field. The second also, yeah. And then the third and the fourth weeks will be discussed. We will discuss about potential energy and electric potential. And the first until fourth weeks, we will study in general electrostatics. Yeah. Electrostatic means doesn't depend on time. It's stationary case. So in fifth, we will discuss about direct current. Direct current means we can distinguish between the pole. Yeah. So it doesn't, the current doesn't depend on time. It's simple case. And then in the 6th week, we will discuss about force and the magnetic field. And also the 7th week, we will discuss about electromagnetic induction. Oh yes, between in the 5th week, we have the common quiz, yeah, common quiz. All of you, together with other class, we'll have a quiz, common quiz. I think, yeah, we have 2 here. Yeah. The first common quiz. Yeah, common quiz, yeah. Joint quiz, something like that. And then, sorry, not common, maybe joint quiz, yeah. TPB joint quiz, maybe, yeah. That's the exact name. Joint quiz, common quiz. Yeah, commons mean usually. Yeah, I mean, yeah, okay, yeah. Yeah, maybe it's similar, yeah, maybe. Okay, this first joint quiz will be on 5th week. And then after that, we discuss about force and magnetic field. And then the 7th week will be discuss about electromagnetic induction. So this is the details of this material course, and this is the goal of this course, of this material. And then we have alternating current, yes, in the 8th week. And then the 9th week, we will discuss about wave mechanics and sound. And then, yeah, this in the 9th week, you will have, all of you will have the first exam in the 3rd April. Yeah. In the 3rd April, Saturday, 3rd April. Any one of you is Advent. Any one of you is Advent. Is there any, sorry, not anyone. Is there one of you is an Adventist, maybe, Adventist or Advent?
I think no, sir.
I don't think so, sir.
Okay, I thought, okay. That's good. I mean, Saturday is not a problem. Okay, good. That makes my work easier. Okay. Okay, after that, in the 10th week, we will continue the study about wave mechanics and sound. Yeah, the second part. And then the 11th week, we will discuss about electromagnetic field. Yeah. And then the 12th week, we will discuss about optical physics. Yeah. First part about interference, yeah. Wave interference. light interference, young interference, two slide, not two slide. Or two slit interference, slit interference, and then the thin film interference. Thin film means it's a thin medium. For example, if you consider the water, and then it's a bubble surface above this surface water. Yeah, this thin thin bubble layer, this thin film. And then you will get also this TPB joint quiz, joint quiz with others, and in the 12th week. And the 13th week, we have the second part of optical physics, discuss about diffraction and interference diffraction. So in this case, we omit the width of the slit. So if we include this the width of the slit, we will have this diffraction. So if you have two slits with width of the slit, and then you have interference and diffraction. Yeah, both we will have this both interference diffraction effect. And then the 14th week, we will discuss about this modern physics. Yeah, it's about photons, wave dualism, wave particle dualism, photoelectric effect, and Compton scattering. But I think, as far as I know, most of the examination, the second examination, this 14 weeks course, but usually it doesn't include in the examination, only until 13 weeks material course. Okay, after the second examination, we will have this RBL examination. Yeah. So you have to give your final report, and then you have to final report and a video related to your activity in RBL. Okay, so this is the reference, main reference. So for the third, for our case, so the main reference is Cardinal Johnson, Introduction to Physics 10th edition. Okay, and also Douglas Giancoli, 7th edition. Okay, I think that is for SAP. List course material. Any questions? Any questions?
No, sir.
I think it's clear enough, sir.
Okay, good. So although the main reference is Cato and Johnson, but I will use also Just 1 second, I forgot the book. Holiday Resnick, ya, Holiday Resnick. Holiday Resnick. Yeah, mostly I use Holiday Resnick because this is the first time I taught FTMD for 3 credits, I think 2 years ago, yeah, but not international class. But mostly I use this book, yeah, this Holiday Resnick and Gerald Walker. Yeah. Maybe you have this book also. So in this, in our course, we will discuss from section 21, chapter 21, sorry. Chapter 21 about electric charge. Okay. Any question? And also other book, I forgot the title, but I will show you if we need to see this book.
Excuse me, sir.
Yes.
Do we have the access for the PDF book, sir, or we have to find it ourselves?
Sorry?
Do we have the access for the PDF book?
Sorry,
Can you hear me?
I don't hear clearly your question.
Okay. Wait. Can you hear me now, sir?
Yes. Okay.
Okay. Do we have access for the PDF book, or we have to find it ourselves?
You have to find it yourself, I think, because I think there is also an ebook, yeah, in particular like Liberagenesis or something like that. You can find this book also.
All right, sir. Thank you, sir.
Yeah. Okay.
Sir, can I ask something?
Just a moment. Yeah. Hello.
Yes,
Hello?
sir. Hello?
Hello.
Yes, I can
Okay.
hear you, sir.
Yes. Okay.
Is the holiday book the 10th edition?
Third edition.
I'm sorry, which one?
Holiday Resnick. This is just 1 second. Extended. The 9th edition. What I have is 9th edition of the Fundamental of Physics Holiday Resnick.
Okay. Thank you, sir.
9th edition. I think you have also 10th edition, but it's not really deep. I mean, the difference, it's not really, it's a minor, not major. There are also some additional material. It's and some task, maybe some task, new task in the edition above ninth edition. Okay, any question again? Okay, if not, okay. You can see my writing.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. What's the color of this? My writing.
It's black.
Black. Okay. Okay. Good. So first of all, let us talk about what you have studied in the last semester about Newton's law of motion. So let us start with the kinematics. Kinematics. So for example, if we have this coordinate system called Cartesian coordinate system, the vertical is y, the horizontal is x, and then in Newtonian mechanics, we consider a particle, which is a point particle, move around the one-dimensional curve. Yeah. So this is the origin, and then this is r here as a function of t, the parameter. So the important assumptions in kinematics, Newtonian kinematics, because we have only one-dimensional curve or path of the path of the particle of a particle. So in Newtonian mechanics, particle means particle means is point. So point that moves around this red curve. Okay, this r here, yeah, is the position vector, yeah, as a function of t. So t here is the parameter, time is the parameter. Okay, so this is the point. Okay, and then from here you can define displacement. This delta means also final minus r initial. So we get average velocity. Average velocity usually like this is a vector, is delta r, displacement divided by delta t, the time interval. You know, as if we take the limit delta t goes to 0, then we have velocity, what we call it, spontaneous velocity maybe, the spontaneous velocity. And then from this velocity, we could also this average of acceleration, which is delta V over delta T. Delta V is the difference of this velocity, spontaneous velocity. And then if we take the limit, we get acceleration, spontaneous acceleration. Delta T goes to 0, delta V over. Okay. So keep in mind that the Newton kinematics, this assumption is important. Particle is a point particle, and then the time is absolute. It's parameter. Okay. Then we have also and then we from here we can also have the problem particle at rest means that this R constant. Constant here is not only a number. It means a constant I write here means the factor, constant factor. The position factor is constant. And then the uniform motion. Uniform motion means that V here constant. Then we get this R, the position factor, is say V0t times R0. This is the initial position, R0. And then you get also another motion with a constant acceleration motion. Yeah, constant acceleration motions. Sorry. This A is constant. So it means that we have V equals to V0 times AT. This V0 is the initial velocity, and then we can also get the position factor is R0 times plus V0 t plus 1/2 AT squared. And then you can also have etc. Everything. Non-constant acceleration motion with A is not a constant. So this is the kinematics. We will use these quantities such as the R, the position vector, the velocity vector, and the acceleration vector in Newtonian dynamics. Newtonian dynamics. So the kinematics, as you know, we study about the quantities that describe the motions, that describe a motion. But in Newtonian dynamics, it means that Newton dynamics means that the source or y, you can say y a particle can be moved. Or we can say, in other words, we can say the source of a particle, the source of the motion of a particle. Okay. So this Newtonian dynamics describe, as I said before, it's related to this Newton's law of motions. What do you know about this law? Reno, what do you know about this motion, this law? Newton's law of motion.
There are three laws.
Sorry?
There are three laws of Newton's law of motion. Sorry.
What do you know? Bagas Irfan,
Yes, sir.
what do you know about Newton's law of motion?
If you don't exert a force on it, it won't move.
Vanes Livaldo,
It is the fundamental theorem in physics.
sorry, can you speak loudly?
It is the fundamental theorem in physics. Like
Fundamental
the basic
theorem of
motion.
no. What my question is, what do you know about Newton's? It means that in the law of motions, in Newton's law of motion, what is the quantity, for example, introduced in this law? Ahmad Rishad Tohir.
Yes, sir. Sorry, sir, but can you repeat the question?
Yes. What Newton's introduced in his law of motion?
So there's the first law, there's the second law, and there's the third law.
I
And
know.
the first law is, sorry.
Yeah, yes. Okay, continue.
The first law is an object will not move unless it was given a force. And the second law is basically F equals to mass and acceleration. And the third law is for every action force, there's a reaction force equals in between and opposite in the opposite direction. That is my guess on Newton's law.
Siapa nih? Suril Josia namanya. Sorry in English. Suril Josia. Halo?
Test.
Halo.
Oh, okay. I think the first law is.
Can you speak loudly? I can hear you. I cannot hear you.
Test.
Yes.
first laws, I think, wait, if an if an object is in motion, it will stay in motion.
I cannot hear you. Can you
Test,
speak
test.
loudly? Louder, louder.
Okay, okay. If the first law states that if an object is in motion, it will stay in motion. And then the second law, I think, before someone say that F equals m times a, and then the third law, if you exert a force, if you exert a force into an object, it will exert the same force back.
Okay, I cannot hear. Okay, Muhammad Arsyata,
Sorry, sir.
Arsatya.
Yes, sir.
What do you know about Newton's law of motions?
So there's 3 laws of motion, and the laws describe the relationship between the motion of an object and the force acting on it.
Okay, that's all. Okay, so what Newton introduced in his law of motion? So in conclusion, yeah, he introduced about force. Force, say the symbol noted by F, this arrow, and it's related to acceleration. So, because proportional to acceleration means that F here is equals to m times a, factor a factor. So m here is the inertia mass. Yeah. Okay. So what happened? So there is maybe a remark here. About this law. First, what happened is m equals to 0. What happened? Umam.
Yes, sir.
Yeah.
Can you hear my voice?
Yes. What happened is m equals to 0.
If it's equals to 0, then it has no force, I think.
Yes, there is no force, but does it have an acceleration? I mean, this acceleration is non-zero.
Sorry, sir, can you repeat the question?
Yes, you said that we don't have a force, mean F is equal to 0. Okay, but still we have an acceleration, right? Non-zero acceleration. Hello, hello? Anyone?
Sir. Excuse me, sir.
Yes. Do
Can
you
I ask?
understand what I mean, what I said?
Yes, sir.
Okay.
Can I ask a question, sir?
If we have m equals to 0 and the vector is non-zero, so we don't have a force exerted on a particle, right? Hello, hello.
Yes, sir.
Hello?
Hello? Yes, sir.
Yes.
We can hear you, sir.
Okay, okay. Just one moment. So what about this case? I mean, you said that in the first law, if F equals to 0, then we have a particle at rest or it moves uniformly. It means that uniform motion, the velocity is constant, okay? If there is no F exerted on a particle, okay? In other words, F equals to 0, okay? Is that correct? Hello, hello?
Yes, sir.
Okay, but if M equals to 0, it seems that we don't have a force exerted on a particle, but it has an acceleration. What does it mean? Muhammad Faza.
Yes, sir. I think if the acceleration is not 0, it kind of doesn't fulfill the first law, since the first law states that the velocity has to be constant if the force is 0. That's my guess, sir.
Okay. Okay. So in this word, in this case, for massless particle, it means that the Newton's law of motions is not valid. Okay. So this is not the case. Do we have a massless particle in the universe? Can you give an example?
No, sir.
I think no, sir.
I think no, sir. Even the smallest protons or neutrons have their own mass, I think.
Massless particle in the universe. Can you state? Can you mention the particle?
I don't think so, sir.
You don't think so?
Sir, is it light?
Yeah, light. The exact name is photon. Photon is the matter properties of light. Yeah. So light usually considered as a wave, but in quantum theory, in photoelectric effect, we cannot longer consider the light as a wave, but as a particle. It has a particle properties of waves, of light. So particle and waves, it's a properties here, a properties of a particle or a thing in the universe. So we have the massless particle. So this is, I think, as far as you know in elementary physics, the photon. Okay, and the second remarks is M less than 0. So I just mentioned directly. This is unstable. Sorry. If you study dynamical system, this M less than 0 is related to the instability. stability of the system. So it means that in the context of dynamical system, if a particle have a mass, the inertial mass is less than 0, then the system is unstable. Do we have the particle that less than 0? Well, theoretically, we have. There is a recent paper in Fisika Review Letters, I think last year, yeah, around T equals 0 Kelvin, there is a phonon with mass, effective mass, is not really a mass, it's an effective mass, is less than 0. They are stable, but in the context of Newton's mechanics, this is unstable. Okay. So the second case, the Newton's law of motion is also not valid. Okay. So it is only valid for m greater than 0. So what you state about the law of motion, the first law, second law, and the third law, it means that this m here is greater than 0. Okay. That's where the case where Newton's law of motion is valid or holds. Yeah. The Newton's law of motion holds to describe the dynamics of particle. Is there any question in this case for this explanation?
Sir?
Yes?
What does unstable mean, sir? Like, does it change its like its values, or is there a more comprehensive explanation for the instability, sir? When the mass is less than 0.
Okay. Okay. There is a book, you search in Google, there is a instability of Newton mechanics. You can search in Google. This is in the context of dynamical system. So this is dynamical system. In the context of dynamical system. You can find a paper or a book related to this dynamical system. It's also discussed about this stability. This stability in this case is the notion stability from Lyapunov now. There are so many notions of stability, but in this case, dynamical system commonly use the notion of Lyapunov. I mean, the stability introduced by Lyapunov. Lyapunov is the name, I forgot the first name. This is a Russian name. Okay, any question? Okay, let us continue. So again about this mass. We know that this is the inertial mass. What's the inertial mass? The mass or the mass quantity introduced by the Newton's law of motion. That's the definition. It means it's related to the dynamics of a particle in the context of Newton's law of motion. Newton's law of motions. Is there any mass beside this m? Let's say mi, mean inertia mass. Mi. This is mi. Is there any mass, or any other mass? Maybe other mass, yeah. Other mass, Do you know other mass?
Is it gravitational mass, sir?
Yeah. Gravitational mass, let's say mg. Gravitational mass. So this is mg is the gravitational mass. This mi is the inertial mass. What is the relation between this mg and mi? What is relation between mg and mi? They have a different names. Okay. What is the difference between mg and mi? Why it is called gravitational mass? Any opinion? Alfino?
Yes, sir.
Yeah, you can say something. Can you say something about this
Maybe
relation? What is the difference between gravitational mass and inertial mass?
maybe gravitational mass depends on the gravity, sir.
Sorry?
Gravitational mass depends on the gravity.
What do you mean?
So like it can be different depending on the gravity. Maybe we go to a planet with more gravity. I think, sir. I'm not really sure.
Thank you. Cynthia Rida Larasati.
Yes, sir.
Yes. Can you say something? What is the difference between inertial mass and the gravitational mass?
Wait, sir. Can I speak in Bahasa?
Yeah, okay. That's fine.
Okay, so hold on, sir. I don't really understand. Wait.
Okay, that's fine. Vanes Livaldo.
I still don't really get it too, sir.
Selina Janet. The distinguish between the inertial mass and the gravitational mass. Yes.
Gravitational mass is it compares the force of gravity of an unknown mass, and the inertial mass compares like an unknown mass and unknown force to an unknown mass.
Sorry, can you repeat again about gravitational mass? What is gravitational mass?
Gravitational mass compares the force of gravity of an unknown mass. Is it?
Okay,
Sorry,
thank
sir.
you.
Yeah.
It's okay, that's fine. The others didn't say anything. Jusaki Bungas.
Yeah, hello, sir.
Yeah. What is the difference between gravitational mass and the inertia mass?
I think if it's a gravitational mass, is just gravity is the force of gravity, while inertia mass is using the second law, about Newton's second law, which is acceleration. Is it, sir? I don't know.
Okay. Thank you for your opinion. Yeah, this gravitational mass is related to gravitational interaction. Introduced by Newton's law of gravitation. So the inertia mass is introduced by laws of motions, is related to the inertia properties of a particle. But Newton, in gravitational mass of a particle, it can be viewed as the source of gravitational field. So this is also the same, similar properties from the electric charge. So the electric charge is the source of electric field. So gravitational mass is the source of gravitational field. So if we have this, the origin, we have this positional vector. This E here is proportional to this M, big M over R squared, R hat. R hat is a unit vector. This R hat means that R vector divided by R. R is the magnitude, the modulus of magnitude of this R vector. Okay, so this is time G. So this is the universal gravitational constant. It believes this is what called universal gravitational constant. It believes by physicists, most of the physicists, that this is the constant of our universe. So our universe, there are some constant in the universe that also could be the clue, the clue or something like, the clue, maybe the clue how this universe was created long time ago. It believes, but maybe at that time this is not a constant, but so far it is believed that this is a constant. Okay, that's the difference. That's the difference between gravitational mass and the inertial mass. But we have something like a so-called equivalence principle. State that the mass, the gravitational mass of a particle is exactly the same as or equals to the inertia mass, its inertia mass. So this principle has been not proof, yeah. There is a physicist called Edvos. So he used the Cavendish, I forgot in English, neraca Cavendish, Cavendish. I forgot in English. This is the name, neraca. On a Cavendish scale, yeah, maybe Cavendish scale, yeah. Maybe Cavendish scale, yeah, Cavendish scale. You're using Cavendish scale. Yeah, to prove this principle, what he get that the experiment is around 18th centuries, long time ago. But he get delta m over m is around 10 to minus 8, I think. But the recent experiment using lasers, recent experiments, we can get around 10 to 12, minus 12. The recent experiment, sorry. What does it mean? It means that if you have, for example, 1 kilogram of a stone, this could be your inertia mass, and the gravitational mass is 1 kilo, 1 plus minus 10 to minus 8 kilograms. So it's very, very small. So it is believed, even we have this order of magnitude, it's very small. People believe that it should be the same. It should be true, I mean. This principle, Mi equals Mg. Okay, that's for now. So let me explain in bahasa Indonesia ya, di summary, kesimpulan. Oke, sejauh ini kita sudah membahas tentang mekanika Newton ya. Jadi mekanika Newton itu terkait dengan kinematika, dengan asumsi, ya, asumsi bahwa partikel itu adalah poin. Jadi istilahnya kalau Newton itu dikatakan ya poin itu partikelnya itu berbentuk titik. Ya. Jadi tidak ada dimensi, there is no dimension here. Ya, tidak ada dimensi di sini. Jadi asumsinya itu yang pertama. Yang kedua, waktu itu dia bersifat absolut atau parameter di sana. Jadi apa namanya? Karena dia itu point partikel titik. Jadi partikel titik ya, point itu partikel titik. Dia tidak punya dimensi. Jadi ketika dia bergerak, ya, itu kurvanya ini menjadi kurva satu dimensi. Oke? Kurva satu dimensi. Secara umum ini sebenarnya saya mengambilnya kebetulan 2 dimensi. Kalau Anda mau ngambil yang 3 dimensi itu juga bisa. Sumbu Z-nya itu keluar bidang ya. Kebetulan itu. Nah, kemudian dari sini di kinematika itu biasanya kita mendefinisikan yang disebut namanya perubahan posisi atau displacement. Ya, delta R, dikatakan delta itu selalu akhir dikurangi awal. Gitu. Akhir dikurangi awal. Jadi R awal, akhir dikurangi R awal. Itu. Kemudian kita dapatkan juga di sini kecepatan rata-rata yang definisinya ini delta R per delta T. Kemudian ini bisa menjadi kecepatan sesaat ketika delta T-nya menuju 0. Ya, gitu. Kemudian untuk percepatan rata-rata itu delta V per delta T, itu menjadi percepatan sesaat. Ya. Itu tinggal diambil limitnya juga sama, limitnya delta T menuju 0, delta V per delta T. Jadi partikel diam itu artinya bahwa R itu konstan, V-nya itu 0 ya, berarti di sini. Ini dalam kurung V-nya sama dengan 0. Gitu. Kemudian ada juga gerak lurus beraturan, kita nyebutnya uniform motion. Itu biasa diambil V-nya itu konstan, ya, jadi posisinya itu bergantung pada linear atau order 1 terhadap T. Oke. Kemudian ini contoh untuk gerak dengan percepatan konstan yang disebut GLBB ya. Sorry, sebenarnya ini bukan GLBB sih, maaf. Ini harus dicek lagi, kita nyebutnya cuma gerak dengan percepatan konstan, jadi A konstan. Ini belum tentu garis lurus ya. Jadi GLBB itu hanya kasus khusus gitu dari gerak ini. Jadi GLBB itu gerak lurus berubah beraturan, itu kasus khusus. Kasus khusus. Saya nggak akan bahas di sini karena itu harusnya sudah diberikan semester lalu. Kemudian dari sini kita meninjau juga tentang dinamika Newton ya. Jadi dinamika itu adalah mempertanyakan apa sumber partikel itu bisa bergerak. Mengapa partikel tersebut bisa bergerak? Penyebabnya apa atau penyebab gerak? Ya. The cause of penyebab gerak lah ya. Penyebab gerak. Kemudian kita juga membahas tentang hukum Newton ya, sekitar kita review bahwa Newton itu memperkenalkan hubungan antara gaya dengan percepatan, ya. Yaitu F sama dengan M kali A, MI kali A, itu dengan catatan bahwa MI di sini itu harus lebih besar dari 0 ya. Sehingga kalau dia itu sama dengan 0 atau lebih kecil dari 0 itu tidak berlaku. M sama dengan 0 tidak berlaku, kalau M lebih kecil dari 0 itu tidak stabil. Tidak stabil dalam konteks sistem dinamik namanya. Dan kestabilan ini adalah kestabilan yang diperkenalkan oleh Lyapunov. Kemudian ada massa juga yang lain, itu adalah massa gravitasi. Massa gravitasi ini dia berbeda dengan massa inersia. Jadi massa gravitasi ini adalah massa yang diperkenalkan oleh hukum gravitasi Newton, ya, dan dia bisa dipandang sebagai sumber dari medan gravitasi. Ya, gitu. Medan gravitasi seperti ini. Nah, hubungan antara massa inersia dan massa gravitasi itu sama berdasarkan prinsip ekivalensi gitu ya. Dan Edvos ya, salah satu fisikawan sekitar abad 17-18 itu menguji coba tingkat validitas dari prinsip ini gitu, dan didapatkan orangnya 10⁻⁸ dan ini sangat bagus ya. Jadi sehingga Dan bahkan penelitian sekarang itu mendapatkan malah 10 pangkat minus 12, lebih kecil lagi. Artinya dengan perkembangan teknologi, orang semakin, misalnya fisikawan itu makin percaya bahwa sebenarnya masa inersia ini dengan masa gravitasi itu sama. Oke, mungkin itu aja dari saya. Kalau ada pertanyaan silakan.